Hello student, let's proceed with this projectile motion. In this video, our focus will be learning this projectile motion. And let's consider a scenario or a case. Let's say you are standing on a ground and you have a ball placed over here and you kick it. When you kick this ball, so let's say this is a horizontal direction and we are calling it by X, and this is a vertical direction. Vertical means upward direction. And if you kick this football, then you'll find this ball is going to be moving like this. Sometimes you will notice it here, you will later on it will be found here, then maybe at this location, then at this location, then after it will descending down, so at this location and here, then coming downside, and finally you will find it's going to hit the ground back again for the first time, and then after you'll find it's going to go again like this and hitting the ground another time, and then keep on repeating this motion. Let's consider only that journey when you kicked the ball and when it lands back on the ground for the first time. This particular situation is going to be our main focus area in this particular video. And whatever this dotted locations I have shown, these are the instantaneous locations of the object at a different time. And let's say you have kicked this object at t equal to 0. So different times it will be located at a different locations. That means at a particular moment it will be at a particular time. So let's say this is a particular times, then it will be located at this location and moving with certain velocity. So we need to understand this motion. That means we need to describe this motion. We need to know where the particle will be at what time, and other parameters related, what the velocity will be, what the direction of velocity will be, what the acceleration will be. So this motion is known as a projectile motion, and in this motion you have given the initial velocity when you kicked it. That means you have imparted a velocity called initial velocity, and we will denote by u later. And this velocity made certain angle with the horizontal direction. So this is theta, let's say, from the horizontal ground. So this is horizontal ground, and that's a vertical we have talked about. So when we can say when a particle is thrown at certain angle from the horizontal direction, then the motion of the particle is known as projectile motion, and that particle or the ball in itself is known as projectile. So projectile is for the ball or the object. And at a different time and different position, we need to talk about velocity and acceleration. This is also known as a two-dimensional motion, because this is not only moving in x direction but also in y direction. So there is a two-dimensional motion, that is, it is moving on. And as I told you, if we consider at any instant of time and we consider this as a velocity, then you can have two components of this velocity. One component that you are going to get is along the horizontal direction, and another component will be in the vertical direction, that means in the y direction. Let's say that velocity is v, and this v is at any time, so that's the general velocity we are talking about. So if we can get this v, that means we know what the velocity at all the times are. So this will have two components. We will treat it as a two component, one in the horizontal direction. So horizontal component of velocity will be written as vx, x for horizontal. Another component will be vy, so that will be y component. That means motion has a velocity in x direction as well as in the y direction. Moreover, wherever this particle at t time is located, we need to know the location. So in order to get the location, what we can do, we can drop this, and we know if this we are considering as an origin, so this will be the y coordinate. So we will say this is a y displacement in the upward direction, and this will be written as a x. So the particle is traveling x displacement in the horizontal direction, y displacement in the vertical direction during the time duration of t second. So this t is a general term. We are interested in the quantities like x and y. If we got to know x, we got to know y, then we can find what the position is, because that will lead to know the coordinate. So position of the particle, that's displacement of the particle, will be written as x I cap plus y j cap. That becomes the position. So we will be knowing the position of the particle completely once we know what the x is at any instant of time, what is y is at any instant of time. Meaning x has to be as a function of time, y has to come as a function of time. Similarly, velocity of the particle can be written as vx in I direction plus vy in z direction. And if we know vx, vy, that means both the components of velocity, then we can find what the total velocity is, because that's a resultant of these two perpendicular components. And then we will be able to know at any time what the velocity of the particle is. Mind it, when we are writing this, that means we are considering both magnitude as well as direction. So our answer will be telling us the direction in which the particle is moving, as well as with which magnitude of velocity it is moving. Making sense? So position we are able to handle, velocity we will be able to handle once we know these unknown quantities. And then comes to the acceleration. So acceleration comes because of force, as we talked about motion under gravity. So this is also motion under gravity, because no other force is acting. Once you kicked this ball, after kicking this ball, you will find this ball is subjected with no force other than gravity. So you will find this entire motion is taking place under the influence of gravitational acceleration, which is constant and vertically downside. So you'll find acceleration in the horizontal direction is going to be 0, whereas in the vertical direction it is going to be g. So we can write it as in one go, that's acceleration in ax direction I cap plus acceleration in ay direction j cap. So if we know ax, ay, our acceleration will be known to us. And as I told you, using this information, we can write ax and ay. So from here, we will find this is going to be basically rewritten. So I'm writing this a in a different way, or putting the values. So ax becomes 0. It's simply minus g j cap. Or you can write in this fashion, it's a g minus j cap. So g is always positive. So g and minus j cap, that becomes the acceleration. Conclusion came out to be that acceleration in the x direction is 0. Now keep in mind, when we are discussing this motion under gravity, we are assuming air is absent, or even if it is present, it's not offering any resistive force, any viscous force, any drag force. So we are assuming ideal conditions. And in reality, you'll find later on, when we are going to deeper into the physics, then you'll find we will start considering this air influence as well. Air influences the motion of the particle in the atmosphere, and that will be the idea when later on that we are going to include. As of now, we are considering air is offering no force, only gravitational force is there. Moreover, we are also considering there's no wind blowing. So there's no wind blowing. So acceleration is also simply this. If at all in a question says the wind is blowing, let's say in x direction, so we will get that acceleration and we will assign that acceleration in the x direction, and our method of solving the equation will remain exactly the same. So this is the most general way we are talking about. So for a description of any motion, we require position, we require velocity, we require acceleration. Hence, we are talking about all these parameters. Now our purpose becomes to find the x as a function of time, y as a function of time, vx as a function of time, vy as a function of time. If we are able to find these general equations, then our job will be done, because acceleration is known to us. And one more point we can notice from here, this acceleration, whatever we are writing, is a constant. So we will be eligible to use all those equations in which acceleration remains constant. So for constant acceleration case, we can use all those equations that we have simplified earlier. Now let's try to write this equation of motion so that we can get x, y, z and all that. So let's say I'm writing equations of motion for this case. Equations of motion. Now, since this is a two-dimensional stuff, so what we need to do, we need to keep the two dimensions separate. Now, in vector, this is important point that x direction motion is not influenced by y direction motion. That means whenever we have x component and we have y component, so x component does not influence y component. So perpendicular motions are called independent motion. So this motion can be treated as a two independent motion, one along the x direction, another along the y direction. For x direction, these are the parameters. For y direction, these are the parameters, right? And when we combine those two parameters together, then we can find the motion in two-dimensional. So we are basically considering this 2D motion as a two independent separate motions. So that's why we will be writing it as x component of motion, x component of motion, or you can call horizontal component of motion, because x is indicating horizontal direction over here. So let's start with this, because we know in horizontal direction what is initial velocity. What we need to know for any motion, if you remember the equations of motion, we need to know u, initial velocity, we need to know acceleration, and then we can find out what the v is, what the position is, and all that stuff. That's what the kinematics is, right? So in x direction, what will be the initial velocity component? So you say this is initial velocity. We can make the two component, one in the horizontal direction, another in the vertical direction. This horizontal component will become u cos theta using the rules of vector, and this will become u sin theta, making the component of a vector. So from here we are able to understand that the initial velocity component along the x direction is u cos theta. Initial velocity along the x direction, I am writing with ux. X subscript is telling us x component. So we got to know u and u cos theta as the initial horizontal velocity. And u will be given to us, theta will be given to us whenever you are kicking the ball like this. That means we need to know what the velocity is by which you kicked it, what the angle is. So these two are the initial values that will be known to us. So if initial velocity values are known to us, we can find what the horizontal component of velocity is. Similarly, we will need to look for this horizontal component of acceleration. We have already talked about. In ideal conditions, it's going to be 0. Now, so that becomes a 0 acceleration case. 0 is a constant thing, so you can say constant acceleration case, or uniform motion. We can also claim whenever the acceleration is 0, velocity remains unchanged. So we will find the velocity in the horizontal direction will remain unchanged, and that's called uniform motion. So projectile will perform uniform motion in x direction. Making sense? And if we want to write velocities, we can write these are the given information. So velocity in the x direction will remain unchanged. That means it will be remain equal to the initial velocity, because the acceleration is 0. So it's going to be u cos theta. U cos theta. So one equation we have got, and that's an extremely important equation. Simple but important. And similarly, we are going to find another equations as well. So we have talked about the velocity component in x direction. Now our focus would be to know acceleration displacement component in the x direction. Since this is a uniform motion and the particle is moving with a constant velocity, so in after t time, how much the displacement it is going to cause, that displacement is basically x. So particle is moving constantly in this direction. In t second, this is the distance it is going to cover. So we will say in horizontal direction, the distance or displacement is going to be x is equal to velocity into time, which is vx into t. And vx, if we place the value of vx, it becomes u cos theta into t. So that becomes the second important equation for the projectile motion. So these two equations are describing the x component of motion completely, right? So we got to know x, which we were looking for. We got to know y, this vx, which we were looking for, and ax is known to us. So you see, we have done with this x component or horizontal component of motion. Now we need to do with the same type of story for the vertical component, which is also known as y component. So we will say y component of motion, y component of motion. Here I'm trying to explain in detail, and you need to focus on all the details because they are extremely important. And once we are able to form these four equations, then we need to use these equations to answer questions related to this kind of stuff. So again, we need to look for the initial velocity in the vertical direction. So that's the uy we are looking for. So uy is this velocity component, and this is directed toward the positive axis. So directions, how we are measuring? Direction we are measuring according to the direction that we have chosen. So in x component of motion, all vectors in the direction of x has been written as a positive. Like look at it. This initial velocity in the x direction is in positive x direction. Similarly, this displacement is in the positive x direction. Similarly, vx is in the positive x direction. Hence, we are writing positive terms. Hey, now we come to the y component. So y component initial velocity is going to positive. So it's going to be u sine theta. Now let's try to write this ay. So this ay direction of acceleration is in the vertically downward direction. So its direction is opposite to the direction that we are treating as a positive. That means it is in the direction of negative y. And in one dimension motion, we know that the number carry the direction. So that's going to be minus g. So in place of ay, we are writing it as minus g. That means this minus is basically of minus of j cap. That means in j cap we need to multiply with this minus, so that talks about direction. So this is direction indicator. And once we have written this initial information, then we can apply equations of motion. You see this is a constant term. Since this is a constant, we can use the equation of motion, which are for constant acceleration in one dimension. So velocity v is equal to u plus at we are going to apply. So velocity in the vertical direction will use initial velocity, which is u sine theta. So this becomes u plus at. In place of a, we need to write minus z and then t. So that becomes the third equation of projectile motion. And what this equation is telling us, this equation is telling us the velocity in the vertical direction at any instant of time. That means for all the times. And if we can use the equation second, or equation of motion second of 1D motion, then we can find the displacement in the y direction, which is we are writing as a y. So now we are finding this displacement in the vertical direction, and it's going to be using ut plus half at square. So u is u sine theta, t is t, plus half at square. A is going to be negative, so I'm going to write minus half gt square. So that becomes the fourth equation. Now these four equations of projectile motion are sufficient to describe the entire motion of this particle. That means we can find out any information related to this projectile motion just using these four equations. So these last two equations are basically talking about this vertical motion completely. So we have handled the horizontal motion, vertical motion separately. Now we can combine the way they have been combined over here to get the final parameters that are relevant for kinematics. Now we will be using these four equations. Let's call them as a name. Let's say this is equation 1, this is equation 2, this is equation number 3, this is equation number 4. So these four equations that we are calling for projectile motion are going to be used. And let's use these equations in some standard questions that can be used or found out or required related to this particular projectile motion. What the standard equation would be like, if you have kicked at equal to 0 from here, one may be interested to find out after how much time it lands over here. That means what is the time of flight, capital T. So we write this capital T. So capital T is indicating total time it takes to come down or back on the ground. That's the total time the particle is in the air. So that's called time of flight. We will talk about. So this is one of the important parameter that we need to find out. Similarly, one can ask what is the maximum height attained by this. So this is going to be written by capital H. So capital H is going to be maximum height. Now it's going to be symmetrical motion. So about this line you will find left side, right side will be identical in journey and path. And then another important information that can be asked from the projection point, how far it lands for the first time. That's called horizontal range, and we are going to write it as a capital R. Capital R. So that's a horizontal range, obvious question to be asked. Maximum height, obvious question to be asked. Time of flight is another obvious question that to be asked. Moreover, when it is at the maximum height, this point also becomes a point of interest. So at this point, we will say the velocity is in the tangential direction. Now we will be using the concept that we have learned. This curve is basically indicating the path. So this is the path of the projectile. This path in technical term is also known as trajectory. Trajectory means path. So trajectory of particle is this. So we need to know what this trajectory or the path is. You will find this path is going to be parabolic. So that's a parabolic path. So let me mention over here so that you can keep in mind this path and trajectory is parabolic. Since it is parabolic, then you can think of one point that it must be having a relation like y is equal to some ax square plus bx plus c, sort of relation between x and y. We will find out what the relation between x and y is, but the path is parabola. That one thing you can find it out. Now in path at any location, if we draw a tangent, so that tangent tells us the velocity direction of instantaneous velocity. So velocity direction can be calculated by drawing a tangent. So at this topmost point, if we draw a tangent, this will be the velocity at this location. Now you'll find this velocity is going to be only in the horizontal direction. So at the topmost position, you'll find the vertical component of velocity is 0. Vertical component of velocity is 0. There is the only horizontal component of velocity. Moreover, we have already talked about the horizontal component of velocity remains constant during its journey because horizontal motion is a uniform motion. Then we can say this horizontal velocity at the topmost position is going to be basically u cos theta. So horizontal component of velocity in the entire journey will remain the same. Hence, we got to know one important point, that the velocity of the projectile at the highest point is in the horizontal direction and it is equal to u cos theta. That's the total velocity in the vertical, this at topmost position. And at any position, if you are looking at this Vx is also going to be u cos theta. That means horizontal component velocity is always u cos theta in this particular motion. Okay, so these are the basic points. Let me quickly summarize, then let's go for the some important obvious questions. So projectile motion, when you throw a particle from the horizontal direction at an angle, and this angle is less than either 0 nor 90, then you'll find it's going to follow a projectile, this parabolic path, and the particle is known as projectile and the motion is known as projectile motion. And these four equations are equations of motion that describe the motion entirely. And using these equations we will be proceeding further. So let's go ahead. So let's the first thing that we are calculating is time of flight. So let's say this was thrown at t equal to 0 and it lands back at t equal to capital T. So you can find it out by using four equations, and you can use your own brain to find it out. One more thing we can say, because of symmetry, when the particle reaches here, it takes similar time to go up, similar time to come down because of symmetry, or otherwise we can prove it. So we can say if t is the total time of flight, then t by 2 is going to be the time it reaches to the maximum height. Now let's say use that equation of y and say when the particle lands back again on the ground, the y coordinate must be 0. So we will say there's an equation y displacement equation. So y is equal to there's a u sine theta into t minus half zt squared. See the fourth equation that we had earlier, and use this equation and you say put y equal to 0. As soon as y becomes 0, then you'll find t must be equal to t. Or you can say when t is equal to t, y must be 0. Because it comes back on the ground, so that's why coordinates become 0. So that's what the logic is, or application of the formula is. Once you have got this point, then what you can do, put the value of y over here, and you say it's going to be 0 is equal to u sine theta minus half gt into t. T you can take outside. It's a product of two things, either this has to be 0 or this has to be 0. Right, so from here we can conclude there are going to be two things, t equal to 0 or this number is 0. When you make that number 0, then you'll find t is going to be equal to 2 times u sine theta by g. So what it says y coordinate becomes 0 at 2 time durations. One time duration is when t was 0, then you say yes, at t equal to 0 y coordinate was 0, and the another is this. So apart from this thing, so this is going to be the next time. So that means whatever the second expression we are getting, that is basically indicating time of flight. So from here we got the formula of time of flight. So we can say time of flight for this particle, or let me write over here, this formula is going to be t is equal to 2 u sine theta upon g. Now if you look carefully, this u sine theta is basically vertical component. That means we can say it's a 2 u, the component of velocity which is in the vertical direction, that means perpendicular to the ground. So sometimes we also write as a perpendicular by g. When I write u perpendicular, that means it's perpendicular component or vertical component perpendicular to the x direction, or vertical component you can call, or we can call it as a y component. So let me write it as a y component so that you are not getting confused. Yes, so that becomes again a result, you can call it. As a result, we are going to use this thing. In better questions, we were directly using this t as a 2 perpendicular component of velocity divided by g. Right. In more general, we will say this component is perpendicular component, and the acceleration is also perpendicular component, because this g is basically ay. Right. So that's the time of flight. This time of flight can also be calculated using information about the topmost point. So you say at the topmost point the vertical component of velocity becomes 0. So as soon as you use you put the vy equal to 0, you will get the t, and place that t as a t by 2. You can verify, you will get the same answer coming in. Next obvious information about this, another parameter that we need to look at is a maximum height. So how we can get maximum height? There can be n number of ways to get this maximum height expression. So this maximum height will be calculated as this. You can see over here. We can also use maxima and minima concept that we have already gone through, and we know the expression of y as a function of time this, and what we need to find the maximum value of y. So you just differentiate it, put it 0, find the t, come back, and you will find this. But we have understood that because this is going to be the topmost point is going to be at a t by 2 time, and at that instant whatever the y is, that becomes maximum. So I'm writing directly over here, that means y will be equal to h, that means maximum height, when t becomes, when this t for time, when this t becomes equal to half of the time flight. And half of the time of flight means it's going to be u sine theta by g, u sine theta by g. And then let's put this value of y in the equation that we have used, the same equation. So this h will be equal to u sine theta into t. In place of t we are going to write as a u sine theta upon g minus half g into t square. That means it's going to be u square sine square theta upon g square. When we do square of sine, so it comes out of sine square theta. You know those mathematical rules. So it becomes u square sine square theta by g, and another term we are going to get 1g is getting cancelled out, so it's going to be u square sine square theta upon 2g. So it's like this is 1, this is a half of it, so ultimately you are going to get a half of it. That means u square sine square theta by 2g. Hence we got another formula that's called maximum height. It's going to be u square sine square theta divided by twice g. You might be remembering this formula from your previous classes, but I'm proving it and writing it down. Now onward we need to remember for sure. Which we can also, this can also be written as a u sine theta is basically vertical component of velocity, and square of this, so you can say vertical component of velocity square divided by twice g is the formula for maximum height attained by the particle. Now when I have written these two formulas finally, then one thing has to be understood from this, that this time of flight is independent of horizontal component of motion. This time of flight is dependent only on the vertical component of motion. This is vertical component, this is vertical component. Similarly, the maximum height is independent of horizontal components. It depends only on the vertical component velocity and vertical component of acceleration. Making sense? So vertical component they are dependent upon. Then we can think of the third important thing that's called horizontal range. You can find this horizontal range by using a method like horizontal range is basically the maximum value of x coordinate, and we know the x expression was x was equal to u cos theta, which is a constant initial velocity, and into t for time. And if you want range to be this x to be maximum, then what we need to do, we need to maximize this term. U cos theta is a constant, so we need to maximize this t. So this t maximum will be time of flight. So from here we can conclude that range is basically initial velocity in the horizontal direction into time of flight. And we can put the value of time of flight so that we can get this expression. So r comes out to be u cos theta into t is u sine theta twice, so twice u sine theta divided by g. So I have divided by whole by g. It's okay. So it becomes u square 2 sine theta cos theta, so that can be combined together to form it as a u square 2 sine theta cos theta, which will become sine 2 theta divided by g. So that becomes horizontal range. So we can write this horizontal range expression that we are getting is u square, that means initial velocity square, sine twice of the angle of which you are throwing it, divided by gravity, that means acceleration due to gravity. If you want to write in terms of component, then you can say this is a x component and this is a y component. So it can also be written as twice vertical horizontal component of velocity, vertical component of velocity divided by g. So this indicates that horizontal range depends on both the components, horizontal component as well as vertical components. So range is dependent on both the components, whereas time period, or this time of flight rather, and maximum height, they are dependent only on the vertical direction motion, right? So these are some obvious quantities. Now since this is a maximum height, so that's a maximum height, that means all other heights, let's say particle, when the particle is here, so this will be known as another height, which is not a maximum. So y is basically indicating the height at any location. So maximum value of y is this, so that's a maximum height. That means particle will be reaching up to this height in its entire journey, and all the other locations will have a height lesser than this value, and this is the range. This is the range. Now there's another term that's popular known as maximum range. So if you want to make your particle to throw in such a way so that it gets maximum horizontal range, so that we write as R max. So how we can get R max? If you choose 1 theta, then you will get one range. Okay, and if theta is a choice, then we can keep on changing theta and checking what is the range is for given value of u. So for a given value of u, range can be maximized for a particular theta. So that means we want to maximize this term for particular for variable theta, or if we are changing theta to make this maximum. So if u is a constant, g is a constant, so we will say sine theta has to be, or sine 2 theta has to be maximized, and we know sine 2 theta is maximum equal to 1. So we will find that range maximum comes out to be, range maximum is going to be equal to u square by g. So u square by g is the formula for the maximum range that can be achieved by this particle performing projectile motion, and this range will be achieved for theta, and we will say when sine theta, or rather sine 2 theta here should be 1. Sine 2 theta is 1. What does that mean? Let's just separate this part. So sine 2 theta is 1 means angle must be 90 degree. That means twice theta must be 90 degree, or pi by 2 we can call it. So from here theta will come out as a 45 degree, or pi by 4. That means in order to achieve maximum range in a horizontal direction, what the angle of projection will be? Angle of projection should be 45 degree. That means if you want to kick this ball to the farthest location from that point of projection, then you'll find you need to make this angle 45 degree. If you are choosing any other angle, then you'll find it will not be reaching to the maximum, rather lesser than that. So this theta is known as the angle of projection, and this point is known as point of projection, and u is known as initial velocity of projection. So these are the terminologies that we use. So these are the basic formulas. You just list them down. Along with these formulas, few results we have already talked about. Let me quickly add here as well, that this velocity remains horizontal, vertical component is 0, and it is simply u cos theta. So topmost position has a u cos theta velocity. Moreover, when it falls back at the same horizontal level, then you'll find this velocity is going to be equal to u, in magnitude, not in direction. So that's going to be equal to u, or you can say the speeds are equal, or magnitude of velocities are equal, and angles are going to be different. And if it were making theta angle, so you'll find this angle from the horizontal again will be theta. So that you can see the horizontal component is still u cos theta, and vertical component becomes opposite of this. So vertical motion is going to reverse its velocity, whereas the horizontal motion will maintain its velocity. That's what happens when it falls back. Make sense? So this is also an additional point that you can remember. When it falls back, has the same magnitude of velocity but different direction. So if the question says whether the velocities are same, you say no, it's a magnitude of velocity which is same. Horizontal component velocity is always u cos theta, and at the top location is only this. That means at the top location vertical component of velocity is 0. So that's an additional point that you can follow. Next point let's consider is equation of trajectory. So let me tell you some general point about this equation of trajectory. Trajectory is basically a path. So whenever we need to find the equation of a path, so it's going to be basically a relation. So this is a relation, or you can say function, between or among, depending upon how many these coordinates are, between x and y, location or position coordinates of the particle. So it's a relation between x and y coordinates of particles. So whatever the particle which is moving, its x coordinate, y coordinate. If it is moving in 3 dimensions, so including z coordinate. So whatever the relation among these x, y, z components are going to be, or location coordinates are going to be, that relation is known as equation of trajectory. So many times there will be equation to find equation of trajectory. So there will be x given, y given. So out of x and y relation, you need to find a relation among x and y, removing all other variables from those equations. So that relation will become equation of trajectory. Basically, it's going to be equation of the path that the particle follows. And if we get the equation like y is equal to ax plus b, then we can think of this is equation of path, which is straight line. And similarly, all other rules that we have already talked about. And this sometimes also called in math language locus of particle. So locus of point means path that particle follows. Anyway, in projectile motion, as we have talked about, this is a parabola. So here we are going to prove that is going to be a parabola. And moreover, we will also remembering what the equation of that parabola is going to be. So we need to find a relation between x and y. So what is x? Do we know x? Yes, we know x at any instant of time. It's a u cos theta into t. So that's one of the equation. Do we know y? Yes, we do know y. Y is equal to u sin theta into t minus half gt square. Now this x is a function of time, this y is a function of time, so time is a variable. What we need to do, remove that variable, eliminate that variable out of this equation and form equation between, or relation between x and y. U and theta are constant, so they can stay there. So y can be written as, so what we need to do, from here we can find the value of t, and we can substitute this value of t in the second equation. So y can be written as u sin theta into t. In place of t, we can write u, this x upon u cos theta. So we are going to write as x upon u cos theta. So I am substituting the value of t from one to another. Minus half g t square. So square of this is going to be x square divided by u square cos square theta. So that becomes, now you see this equation carefully. In this relation, only x and y are variable, rest are constant. So that will be known as equation of trajectory. Now we can simplify it a bit. So when we simplify it a bit, u is getting cancelled out. So it becomes x tan theta, or tan theta into x, minus, here if you find anything getting saddled down, so nothing is getting cancelled out. So it's going to be minus gx square divided by 2 times u square cos square theta. So that becomes a relation between coordinates x and y. So that will be known as equation of trajectory, an important relation that we need to keep in mind. So if u is given to us, theta is given to us, g already we know, then you will find this is going to be a relation between x and y. If you compare this, it's written some sort of this, like y is equal to some ax plus bx square. So this is how this equation is, where a, b are constant. So it's x square and x terms. So from here we can say this is a parabola. Moreover, we know one more point about this parabola by looking at the coefficient of x square. Now here the coefficient of x square is b. So we compare the coefficients. So a is basically indicating tan theta, and b is indicating minus g divided by twice u square cos square theta. Now you see u square cos square theta into 2, they are positive, g is a positive, so this comes out to be negative. So b is a negative. Whenever the coefficient of x square comes out to be negative, you say it's a downward opening parabola. That means like this. And you look at the trajectory, then you'll find this is basically downward opening parabola, right? So if somebody asks to prove this, in let's say in board exams or in somewhere, that it moves on a parabola, these are the steps you need to follow and prove that this is a parabola and this is the coefficient of x square, this is the coefficient of x. Making sense? Okay. So let's finally have this homework problem, and that's related to the equations that we have learned. And it says find the velocity of projectile when velocity makes alpha angle with the horizontal. U and theta is given, so that's a picture. U is known, theta is known. That means you can use U and theta in your answer. And we need to find the velocity when it makes theta alpha angle. So let's say this is the velocity that we need to find, and given that is this angle is alpha. So just try to solve it and give the answer in the comment section. And if you can use this, find the answer, that means you have got to know what these basic equations are, and you will be able to use this. And then you can do a lot more practice with the appropriate material. So in this video we have learned about the basic about this projectile motion and all related aspects. So make your notes, and if the doubt you can always ask. Thank you for watching. Have a great time.